RAID Basics. RAID stands for Redundant Array of Inexpensive Disks. This is a standardized method for managing multiple drives with a RAID controller. This gives you redundancy and higher performance than you can get with a single drive. It allows you to have higher capacity logical drives than is possible with one drive. Hardware RAID controllers are what you want to use for servers, and they're used to manage multiple drives in a RAID array. A server RAID controller can have dedicated cache memory, usually with a battery backing behind it. The cache in a RAID controller can be used for reads or writes, or combined for both. There are several different RAID levels that are commonly used for servers. The first one is RAID 1, next we have RAID 5, then you have RAID 50, and then finally you have RAID 10. RAID 1. RAID 1 is called mirroring. It requires two physical drives, and your data is copied to both drives. So because of this, it requires a 50% storage space overhead. So if you have two 300 gigabyte drives in a RAID 1 configuration, you only have 300 gigabytes of space after the RAID 1 has been applied. This drive array can survive the loss of either one of the drives. If one of the drives fails, you're going to have to replace the failed drive, and then the RAID controller is going to automatically rebuild the mirror. And you need to do this as soon as possible, because if you lose the other drive, obviously you're going to lose your data. Now there's no performance impact after you lose one drive in a RAID 1 array. It's very common to install the operating system in a server on a RAID 1 volume. So that means you have two drives that are managed by your RAID controller, and they're in a RAID 1 array. That way, if you lose one of the drives, the server won't go down. So again, this is usually done with two internal drives in the server, and it allows the server to operate normally after losing either one of those two drives. So it's sort of a standard thing that you do with most servers. The next common RAID level is RAID 5. RAID 5 is called striping with parity. RAID 5 requires at least 3 physical drives, and your data is striped between all of your available drives. After the data is written to the drives, your RAID controller calculates parity information, and then that's also striped between all of the drives. This causes a write performance penalty for RAID 5. Having this in place allows the array to survive the loss of any one drive in the array. If you lose a drive in the array, your performance is going to be severely affected because the RAID controller has to read the parity information from the other drives to reconstruct the missing data from the drive that failed. That failed drive has to be replaced as soon as possible, because if you lose another drive in that RAID 5 array, all of the data is lost. RAID 5 requires 1 over the number of drives as storage overhead for that parity information. So if you have a 4-drive array, you're going to lose 1/4 of your space for parity information. RAID 5 is very popular with IT departments. It's quite economical because of the low storage overhead, and the risk of failure actually goes up as you add drives to the array. So if you have 3 drives in an array versus, say, 8 drives in an array, the risk that any one of those drives in the array is going to fail is the same, but having more drives makes the overall risk of failure go up. So it's riskier to have more drives in a RAID 5 array. The next common RAID level is RAID 50. RAID 50 is called striping across multiple RAID 5 datasets. This requires at least 6 physical drives. You have to have a minimum of 2 3-drive RAID 5 arrays to build a RAID 50 array. This requires 1 over the number of drives in each RAID 5 array for your storage overhead. RAID 50 arrays can survive the loss of 1 drive in each RAID 5 array. This gives you better performance than RAID 5 after the loss of any one drive. and it can be a good compromise between RAID 5 and RAID 10. RAID 50 is less expensive than RAID 10, and it's more expensive than RAID 5, but provides better redundancy than RAID 5 does. Now, not all RAID controllers support RAID 50, but if your RAID controller does support it, you might want to consider it instead of RAID 5. Next, we have RAID 10. RAID 10 is called a striped set of mirrors. Your data is mirrored and then striped across multiple drives. With this setup, it's possible to survive the loss of more than one drive. RAID 10 requires a minimum of 4 physical drives, and the number has to be an even number when you're using RAID 10. RAID 10 does not have a write performance penalty like RAID 5 does or RAID 50 does, so it's very well suited to write-intensive workloads. RAID 10 does require a 50% storage space overhead, so it's a lot more expensive than RAID 5. Sometimes RAID 10 is called rich man's RAID. RAID 10 is very popular with database administrators because it provides better write performance and better redundancy than RAID 5. On the other hand, RAID 10 is less popular with IT departments and SAN administrators because, again, it's more expensive than RAID 5 or RAID 50. But if you have a very write-intensive workload, you should be looking to use RAID 10 if you can.